Thank you for giving me the opportunity to present the paper entitled From Remote-Controlled Excavators to Digitized Construction Sites. My name is Johannes Schoenboeck and I'm a full professor at the University of Applied Sciences here at the campus in Hagenberg. Together with my colleagues, I'm leading the research group Personalized Environments and Collaborative Systems, where we also do research on new forms on human-machine interaction. This work has been done together with Wacker Neuson, which is a leading manufacturer of construction machinery, and I will present the results of a project work done by master students of the degree program Software Engineering and Communications and Knowledge Media. The main motivation for this project is that operating excavators often causes dangerous situations, for example doing demolition work or cleanup work during a flood. In addition, excavator operators are very often exposed to situations that can affect health, for example noisy surroundings, high temperature or dust. Furthermore, it was observed that there will be a shortage of young, well-trained excavator operators in the near future. Currently, the majority of excavator operators are male and around 50 years old. Thus, means to make work more attractive and easier are heavily needed. Also, the construction industry is the largest sector worldwide. It is one of the least digitized industries. However, digitization could make an enormous contribution to safety and lead to more comfortable working environments. A first fundamental step towards the vision of Construction Site 4.0 is the necessary equipment of construction machines with corresponding sensor technology, which enables a multitude of automation possibilities. Construction equipment manufacturers are currently experimenting with ways to remotely control excavators, among other things, to keep excavator operators out of the immediate danger zone, e.g. during demolition work. The focus of this paper is not on the hardware level, but on developing and evaluating visualization concepts for remote controlling of excavators. These concepts are then prototypically implemented and evaluated by a user study, used to derive further steps towards the vision of Construction Site 4.0, like teleoperation of excavators. As already stated, we conducted the project together with Wacker Neuson. It started in October 2020 and ended in June 2021. Within the framework of a human-centered design process, a first prototype was developed, where the excavator can be controlled with the help of a PS4 controller, and corresponding information is visualized on a smartphone directly mounted on the PS4 controller. To understand the context of use, we conducted interviews to gain insight into the processes involved in operating an excavator, as well as specific requirements of the excavator operators that need to be visualized in an according user interface. In addition, important environmental influences and the rules on construction sites could be learned in order to identify important dangers and problem areas. Unfortunately, only 3 persons could be interviewed due to the strict COVID restrictions. All 3 persons were experienced male excavator operators. The findings can roughly be divided into the 2 sub-areas, UI elements and control. Concerning UI elements, one opinion that was expressed by all test persons was that the engine temperature, the cooling water, the fuel level and the engine speed should always be displayed. In addition, information on the stability of the excavator would also be necessary, e.g. whether there is a danger of tipping over. Furthermore, information on the hazards in the tipping area or in the surrounding area should be visualized. Test persons can well imagine to control the excavator via a PlayStation controller. However, care should be taken to ensure that several buttons do not need to be pressed simultaneously, to achieve the desired result. Another aspect that might complicate the operation is if the excavator reacts too fast or too slow to user input, meaning that sensitivity should be configurable. Additionally, it is of utmost importance to minimize latency, meaning that the response of the excavator must be in near real time when corresponding buttons are pressed on the controller. In order to derive requirements, the main findings of the interviews were clustered. We then formulated user stories and visualized them by drawing a storyboard as shown in the picture. Thereby, we mainly focused on a common scenario, digging a hole with the excavator. Several hardware solutions were considered for controlling the excavator in the remote scenario. These included VR or AR classes, a joystick, and connected devices such as smartphones and tablets. Due to availability and realistic feasibility, a PS4 controller was finally chosen with an additional attachment of a smartphone. The button assignment for controlling the excavator using the PlayStation controller was already specified according to the standard ISO norm, which we applied for our design and the prototype. In order to be able to view the working area accurately, an overview of the surrounding is suggested, e.g. the working area or material placement may be thrown in. Additional information about hazards in the working area is also considered, e.g. power lines or water lines. This representation is proposed for the preparation phase. Due to frequent rotations, obstacles within the string radius may not be immediately visible. Especially for people within the string radius, this is a high safety risk on construction sites. Thus, an additional visualization was designed that displays the swing radius, as can be seen here, and represents non-moving obstacles located within the radius by a colorless point cloud. In contrast, moving objects such as beeples are especially highlighted. To distinguish different notifications according to their urgency, they have been divided into three categories: notification, warning, and blocker. Notifications do not require any further action. A simple short beep is sufficient to inform the excavator operator. Warnings indicate a fault that is not yet relevant for safety. For this purpose, the visual notification should be enforced by vibration and a signal tone to draw attention to the fault. Blockers are safety-related notifications that require immediate actions. Therefore, they are highlighted in color and supported by a strong vibration of the controller and a loud alarm sound. If the excavation process begins, a lateral view is recommended, as this allows the depth of the pit to be seen and possible obstacles to be viewed from a different perspective. It would also be good to have a visualization of the current as well as the desired target state in order to know whether the digging process is finished or not. The prototype is implemented in Unity. The excavator was a prototype which will be continuously equipped with new controllers and sensors. Currently, the excavator can receive commands from the PlayStation controller and translate them into movements of the excavator. The communication is done via the WebSocket protocol. The digital twin of the smartphone can be moved accordingly, and data regarding the state of the excavator can be displayed. Due to the lack of sensor technology, the concepts for navigation and orientation, visualization of the excavation, and individual notification and status messages could not fully be implemented in the first version of the prototype. Thus, some of the interfaces presented before remain on a conceptual level. The designs as well as the prototype were repeatedly discussed and tested with developers and people from Wacker Neuson to ensure that their requirements were met. Finally, the prototypes and design concepts were tested by excavator operators in a real environment. The following rough objectives were defined as objectives of the user study. Does the prototype offer advantages for users in terms of efficient operation of the excavator? Is the prototype intuitively usable and user-friendly? What future developments would be useful for the prototype? The user study was conducted with 3 test persons due to COVID-19 restrictions and lasted about 90 minutes per person. First, the PS4 controller was introduced with the help of the digital twin. Within a few minutes, the essential functions and assignments could be learned in a playful manner. Subsequently, the test persons were asked to perform the following tasks using the prototype and the physical excavator. First, move the excavator to the excavation location, meaning turn on the excavator, raise the dozer plate and move it there. Second, dig a hole and dump the earth at the defined location. Finally, backing up and parking the excavator. The statements made by the subjects and impressions gained during the performance of the tasks were then recorded by an observer, meaning that the thinking aloud study was conducted together with guided interviews. Concerning the results, the test subjects had a good feeling using the PS4 controller. However, the assignment of the controller was not intuitive for all test subjects. It should therefore be possible to configure the assignments of the control elements individually. Considering the notification and status information, the view of the excavator from the side was not intuitive, and the display of the error location on the excavator was not relevant for most of the test persons. On the other hand, critical information should be visualized not only when occurring. For example, the tilt angle is important to see during the whole operation. Concerning navigation and orientation, a visualization in which the excavator is directed upwards is more intuitive. The abstract representation of the obstacles is sufficient, as the type of the obstacles is irrelevant. However, the height of the obstacles is an important information that was missing in the concepts. Obstacles should be made recognizable before they are within the swing radius of the dredge, whereby especially moving obstacles should be highlighted and accordingly visualized. The indication about possible hazards is useful. Additionally, a visualization of the material type was desired, for example, to know how close the excavator can get to an excavation pit. In general, haptic feedback was desired, which was rarely included in the prototype. The concepts presented for navigation and excavation were useful and should be integrated into further prototypes. Additionally, a display of the interior view of the cabin should be considered, as this is common for the test users. However, the current functionality of the prototype was not sufficient for a safe and convenient operation, especially if the field of view of the excavator is not that good. Nevertheless, the results are a first step towards a digitized construction site. However, missing sensors hinder further use cases. Even in the remote scenario where the operator still can see the excavator, cameras were explicitly desired that show the exact position of the bucket or to provide a view into the excavation pit. One promising technology that should be integrated in the near future is LiDAR. With this technology, the visions from the design concepts for detecting the environment could be realized. In a first step, we plan to simulate different sensors and test them in according user studies. More sensors may also allow to sync towards teleoperation. Teleoperation does not require direct visual contact between the excavator operator and the excavator itself. Efficient transmission of stereoscopic 360-degree videos in real time is particularly important in order to achieve a realistic impression. Additionally, new multisensory forms should be explored, for example, force feedback, voice commands, or virtual touch for interaction with the aim of achieving a realistic experience. Currently, missing or insufficient digital plans limit possible scenarios. For example, the cores of the excavation pit are usually marked by hand, which are usually not permanent and are often lost again in the course of the work. In addition, the corresponding measuring and marking is an error-prone work. Finally, the excavator operator usually does not have a detailed information about hazards in the subsurface, for example, water or power lines. Having such plans could ensure that excavation can be carried out at a low risk. For example, one could make use of GPS together with augmented reality technologies and various sensors on mobile devices to locate as well visualize utilities in real-world scenes. It should not only be possible to display existing plans, but also to keep them up to date as automatically as possible. It may be possible to automatically determine the course of the laid lines during the excavation process. This information should then flow back into the digital construction information models as automatically as possible. In this respect, we believe that digitization in the construction industry is still in its infancy, needing further research. So in this respect, we plan to continue our work with Wacker Neuson in the near future to get one step closer to this vision. Thank you for your attention.